Assalamualaikum and good day. My name is Muhammad bin Zainuddin and we will present simulation assignment using ETAP for group 10. So this is our team member, me as Imtiaz, Hadif Imran, Firdaus and Daniel Zulkifli. So this is the power system network circuit that the default one that the doctor gives to us. So we using the parameter for set 10 because we are from group 10, which is the such as bus 1 voltage is 132 kV and the bus 2 voltage is 22 kV. So I will present the first question of this assignment, which is load flow analysis. So this is our network circuit after we run the load flow calculation. After we run the load flow mode, we will get the maximum load current at each relay, relay 1 until relay 13, as shown as at the table. So for the next part is we will do the short circuit analysis. So after we run the short circuit mode, we will see all the buses will turn into red and we will get the value of the fault current. So we can tabulate the data of the short circuit analysis in max fault current in kilo amperes for the bus 1 until bus 5. So for the part C, I will do the presentation about the transformation ratio of the CT class 5P CT and accuracy limit current. So after we got the max load current and the fault current, we also can find the CT transformation ratio using the formula ALF equal to fault current divide to CT primary, and we also can find the ALC, which is accuracy limit current. We can ALF we multiply with rated current of CT secondary. So as shown at the slide, that is the calculation for the relay 1 and the relay 2. This is the calculation for relay 3 and relay 4. For the relay 5, we got a little bit different at ALF, which is 20. So this is for relay 6 and relay 8, which is at the bus 2. And this is for the calculation relay 7 and relay 9 at the bus 3. So this is the calculation for relay 10 and relay 11. The last one is relay 12 and relay 13. After we got all the calculation, we tabulate the data at this table, each of the relay from 1 to 13, which is maximum load current. We have CT ratio, maximum fault current, accuracy limit factor, accuracy limit current, and their class. So that's all from me. Thank you.
Assalamualaikum and hi, my name is Muhammad Imran and I will continue our presentation for question D. For question D, the question asks us to determine the values of the pickup PU settings and the time dial settings TSM of all relays to ensure a coordinated protection system. Okay, so generally for this question, we must calculate the value of RSI, that is pickup settings, and the TSM. So for all the 13 relay, so we use all this formula given to get the value of RSI and the TSM. Okay, firstly we calculate for the relay 13. We get the RSI 150 and the TSM is 0.1, and the relay 12 RSI 1125 and the TSM is 0.1. Okay, this is the calculation of relay 11 and relay 10. Okay, for the relay 9, the calculation is a bit long, but we get the value. Okay, for the RSI, we calculate as usual. We get 1/400, but for the TSM, we must use the ROT for relay 9. For the relay 12, I'm sorry, because relay 12 has the higher ROT compared to the relay 13. So we insert the value of ROT to relay 12, and we can calculate the new ROT for relay 9, and we insert the value for calculation for TSM relay 9. Okay, similar for relay 8, we calculate the RSI as usual, but for the TSM value, we must use the ROT value for relay 11 because ROT for relay 11 is higher than relay 10. Okay, then we insert the value, and finally we get the TSM is 0.1836. Okay, for the relay 7, because relay 7 is in the same section as relay 9, so we use the ROT for relay 9, that is 0.483, and then we can get the TSM value for the relay 7. The RSI we calculate as usual, and we got 1300. Okay, for relay 6, we calculate the RSI value as usual. We got 2000, but for the TSM value, we use the ROT for the relay 8 because it is at the same section. And we got the TSM value 0.1455 second. Okay, for the relay 5, calculate the RSI as usual. We got 300. And for the TSM, we use the relay 7's ROT, and plus with the delay time we can get the new ROT, and we use it to calculate the TSM, and we got the value 0.3674 second. Okay, for relay 4, the RSI we calculate as usual. We got 1500, but for the TSM value we use the ROT for relay 5 plus the delay time, and we got the new RAT, and then we can calculate the TSM value, that is 0.3720. Okay, for relay 3, we get the RSI value and the TSM value similarly to the relay 4 because it depends on the both relay depends on relay 5. That's why we got the same TSM value and the RSI value. Okay, for the relay 2, we calculate RSI as usual, 150, and for the TSM value, we depend the ROT value for relay 4, that is 2.3496, and we plus it with the delay time, and then we get the TSM value is 1.3815. Okay, for relay 1, we get the RSI value similar to the relay 2, and the TSM value also similar to the relay 2 because relay 1 is depend on relay 3's ROT. However, ROT value for relay 3 and relay 4 is similar, so we finally will get the similar answer also, that is 1.3815 second. Okay, finally, after we calculate all the 13 relays, we tabulate the value in a table. So this is our table, and to insert it in the ETAP software, we click on each relay's component, and we open the tab OCR, and we change the value for the pickup, that is RSI at here, and the TSM at here. Okay, that is all for me for question number D. Thank you.
So my name is Muhammad Daniel bin Muhammad Zayapli. For the next part, which is for the part E, we want to produce the time current coordination curve of the relay on the system. So before that, we need to click on the star protection and coordination to switch the current present to the star. So after we doing that, we select all the relay 1 until the relay 13. After we select all the relay, we need to create the star view. After we create the star view, we can click on the star system. So here we gain the curve for is relay curve. So after that, I will turn on the grid. So here is the curve for each relay from relay 1 until relay 13. So in the x-axis, we is the times in second. So in the x-axis is the multiple of rated current. So I turn off back to obtain the clear view. So for the next part, which is relay 13, we can see relay 13 in the blue curve. For the relay 12 in the green curve here. For the 11 relay 11 is the dark blue one, and for the 10 relays we can see the yellow line, and for the 9 we can see the maroon color one curve. So until the relay 1. So from this we can also obtain the pickup time and the CT ratio for each relay. For example, we can see the CT ratio for the relay 1 is 200 to 1 ratio, and for the relay 3 we can see the CT ratio is 2000 to 1. So to conclude all of this, I can say all these relay characteristic I assume as a standard inverse characteristic that is called a IDMT relay. So which is operating time is approximately to the fault current. Thank you.
Hi, my name is Mohammed Firdaus and I will talk on part F, which is confirm the sequence of relay operation of the relays for 3-phase short at each bus. So when the fault occurs at bus 5, the relay 7, relay 8 and relay 9 occur at the same time, which is 10 milliseconds. And if the fault occur at the bus 4, the relay 6, relay 7 and relay 8 also happen at the 10 milliseconds, same like the bus 5. And when the fault occur at bus 3, you can see that the relay 6, 7, 8 and 9 is occurred at the 10 milliseconds and it occurred at the same time. When the fault occur at bus 2, we can see that the relay 6, 7, 8 and 9 also occur at the 10 milliseconds. And last but not least, you can see at the bus 1, when the fault occur, the relay 1, relay 2, relay 3 and followed by relay 4 is occur at the 15.7 millisecond.